So this is the start of the pulley. This is not in the plans, but I wanted a pulley on this. So after drilling a bunch of holes and doing a lot of machining, this is what I ended up with. And I installed a set screw on it. This does not get a gib key, it just gets a straight key. The pulley needs crown on it in order for the belt to stay on it, so I set it up on an arbor in the lathe and then cut crown into it from both sides. Here's the pulley installed on the engine to see how it's going to look. Here's a side view of the pulley and you can see the crown. The flywheels do not have crown on them. They are just straight across. So here's the start of the bolts for the cylinder head. I made all the bolts for this engine because I like the high crowned bolts, so I made them extra high and then domed them on the top. You can see the socket head cap screws in there, which will get replaced, but I've already made the bolts for the connecting rod. Here you can see the bolts that I made for the cylinder head. This is the start of the camshaft gear. So it's brass and it gets a magnet installed into it for the Hall effect sensor. You'll see more of that later. This is the planer back in action, and I'm starting to machine the governor, the part that holds the governor arms. This is the governor arms and the part that was machined out on the planer. It was machined out a groove to hold these two arms. This holds the fly ball. Here we are set up to make the crankshaft gear. So we're set up on the horizontal mill with an involute cutter and a indexer. Here's the crankshaft gear finished. And a side view of the crankshaft gear. And another view of the crankshaft gear. We then cut the teeth on the camshaft gear that you saw the blank for earlier. Here's a close-up of the gear teeth for the camshaft gear. Here's the two gears together, and we'll put them on a mandrel and test them out. Here's a close-up showing the mesh between the gears and the backlash. This is the start of the camshaft. The camshaft profile is rounded on top and then it's completely straight on the sides. Here's the finished profile of the camshaft and a side view showing the camshaft. And there's an oil hole in the bottom. Here's the camshaft installed on the cam gear, and it will get Loctited to it. Here's another view showing the camshaft on the cam gear. This is the push rod for the exhaust rocker arm. So the roller on the right, that rolls on the camshaft and then pushes the exhaust rocker and the exhaust valve open and closed. And the little piece in the middle is a catch lever, and you adjust that back and forth to set where it latches and unlatches. You'll see that in an upcoming video. This is the piece that you adjust. This is the lever that catches that piece that you adjust. This is the piece that sets on the crankshaft that moves in and out, that moves the lever that catches on the exhaust rocker arm. This is the rocker or the arm that catches on the exhaust rocker arm push rod. You can see the blade on the left that we made earlier. and the round roller on the right is what goes in the valve that slides back and forth on the crankshaft. I got a video showing how this works later, it'll all make sense. These are the flyball governor arms. So the arms on the left is what goes in the valve piece that slides back and forth on the crankshaft, and then there's a spring on the connection on the right. This is the start of the oil cups for the crankshaft. We're machining on the oil cups and the finished oil cups. Here we are set up to machine out an elbow that was cast. This is for the intake for the carburetor. It's more of a fuel mixer than a carburetor because there's no throttle valve in it. Here's another view showing how I set the vise up in some angle blocks to drill out the intake elbow. Here we are starting the carburetor. Another view of the carburetor or fuel mixer. And here's that elbow that we machined earlier with the rest of the components to make up the fuel mixer. You can see the valve to adjust the mixture. And then at the top where the nut is where the fuel line connects in. Here's another view showing it. Here's the view from the front. So you can see the crossbar in there, that's where the fuel comes in from the right, and then you adjust the needle valve on the left, and then there's a really small hole vertically where the fuel comes out into the airstream. Here's the dripper for the piston. Here's an in view showing the fuel mixer installed in the cylinder head. On the fuel mixer is the lever arm that controls the push rod for the exhaust, and then the camshaft and crankshaft gears installed. Here's a view showing the mesh between the crankshaft and the camshaft gears. Here's that valve that we machined earlier, and you can see the roller down on the bottom in the middle that slides back and forth. So as this piece slides back and forth, it moves the lever arm, which locks and unlocks the push rod, which controls the exhaust rocker arm. This is the hit and miss action of the hit and miss engine. Here's everything mocked up with the push rod for the exhaust. Here's a top view showing the same. Here we are machining out the flywheels to balance them. So there's a groove that gets machined out. This is the start of the fuel tank. So on the left you can see the cap to put the fuel in, and on the right is where the fuel comes out of. These are the two pieces. So here I'm checking the depth of the piece where the fuel comes out because I want it to be able to pull fuel all the way from the bottom of the fuel tank. Here's the piece with the check ball installed. So on the end of it, there's a ball and a spring. So as it sucks fuel up, the fuel can only go one way. It's a one-way check valve. Here's the ball you can see on the end, and there's a really light spring behind the ball. Here we are starting to wind the springs on the lathe. So we're going to make springs for the intake and for the exhaust, and then there's a spring for the governor. Here's the intake and exhaust valve springs made. They are slightly different wire thicknesses. And the spring made for the governor. The plans give you the wire gauge to use for this and how many wraps and how long the springs are supposed to be. And here's the governor mocked up with the spring and the ball. And you can see the two arms in the middle. That's what hooks into that valve that slides back and forth on the crankshaft. Here's the governor installed on the flywheel. Another view of the governor, closer up view of it installed on the flywheel. Those two holes we have to have to drill and tap those out for some countersunk bolts. Here we are drilling out the flywheel for the bolts to bolt the governor to it. And a close-up view. These are 256. Here's the governor installed and back on the engine. Here's an in view showing the governor balls, and the spring's missing, but there's a spring that connects these two. We're going to test everything out here in a second. Here's the governor on a test fixture that I have so I can test the springs out. At a certain RPM, you want it to slide, that valve to slide, and then come back down, and you can change where that is with the different spring tension. This is the piston installed on the connecting rod. And there's a little small brass tube in there that actually the oil that comes from the dripper will actually drip down and lube the piston. And then it'll drip through that hole and actually lube the small end of the connecting rod. Here we are starting the ignition system. This is from modelengineignition.com. It's an electronic buzz coil, and I got the unassembled kit, so it comes with all the components that you solder everything to the board. Here's the board after everything's installed. And I 3D printed some components to hold the board and to mount the ignition coil and the battery box and a switch. It's just on a temporary board right now. We'll test it out and see if everything works. Here we are set up to set the ignition timing. So there's a magnet inside behind the camshaft gear. Sensor back and forth to set where the ignition timing is. Well, it runs, so now it's time to make a skid for it. So my dad made this skid for me out of oak to mount the engine to. Here's a backside view showing the skid. And all the electronics get mounted under the inside in the skid under the engine, hidden out of the way. There's a door in the back that opens so you can access to change out the batteries or to turn the switch on and off. Here you can see the on and off switch on the left, and above the battery box there's a voltmeter so I can keep a watch on the batteries, how much voltage they have. Now it's time for paint. Here's the fuel tank installed on the skid. And everything's put back together after it was painted.